Good morning, dear students, and welcome back to our today's session. We are studying about nitric acid, and we are now left with the last topic according to new reduced syllabus, and that is the oxidizing nature of nitric acid. So let's see the reduced syllabus. Now over here we have to study an oxidizing nature of nitric acid. That means nitric acid as an oxidizing agent with the help of reaction with copper, carbon and sulfur. So this is the last topic left from the chapter nitric acid. So without doing delay, let us start our today's class. So nitric acid as a strong oxidizing agent. Nitric acid is a strong oxidizing agent and oxidizes vigorously metals, non-metals, inorganic compounds and organic compounds. That means nitric acid oxidizes almost all different types of compounds or elements. But what causes nitric acid to be such a strong oxidizer? Let's try to understand that. Nitric acid being decomposable. I hope you remember when we did laboratory preparation of nitric oxide. The nitric acid produced appeared yellow in color. Why? Due to the presence of nitrogen dioxide, which is formed due to decomposition of a partial amount of nitric acid. So nitric acid being decomposable decomposes to produce products such as nitric oxide, nitrogen dioxide or nitrous oxide, along with the production of nascent oxygen. And what do we mean by nascent oxygen? It is the atomic form of oxygen during the production. So it is this nascent oxygen which is very important product formed due to decomposition of nitric oxide, gives the characteristic property, oxidizing property to nitric acid. So the nascent oxygen produced formed from the decomposition of nitric acid is responsible for the strong oxidizing nature of nitric acid. Let's try to understand this particular decomposition. So when we use concentrated nitric acid, the concentrated nitric acid decomposes to produce nitrogen dioxide gas along with water and nascent oxygen. Whereas when we use dilute nitric acid, it decomposes to produce nitric oxide gas along with water and nascent oxygen. So here you have to remember two things. One, when we use concentrated nitric acid, we get nitrogen dioxide gas. And when we use dilute nitric acid, we get nitric oxide gas. So these two gases are important, and we get nascent oxygen as well in both cases, which is responsible for the oxidizing nature of nitric acid. So let us try to understand the action of nitric acid on non-metals first, and according to your reduced syllabus you have to study action of nitric acid on carbon and sulfur. So when nitric acid, concentrated nitric acid reacts with carbon, we get carbon dioxide. So carbon gets oxidized over here to carbon dioxide, to water, carbon dioxide and water, along with the production of nitrogen dioxide gas. Why? Because we are using concentrated nitric acid. The same way, when we treat concentrated nitric acid with sulfur, sulfur gets oxidized to sulfuric acid along with the production of water and liberation of nitrogen dioxide gas. Here again the gas is nitrogen dioxide. Why? Because we are using concentrated acid. Now let us see the action of nitric acid on metals. Nitric acid reacts with all metals except gold and platinum, which are regarded as stable metals. Nitric acid does not produce hydrogen gas with metals. Why? Because due to the very strong oxidizing nature of nitric acid, the hydrogen gas produced gets oxidized to water by the nascent oxygen, and hence we do not get hydrogen as the end product. Instead of hydrogen, we get water as the end product. Its action, the action of nitric acid on metals, depends on two things, and they are temperature and concentration of the acid. Let's try to understand these two conditions, taking some example, and especially copper, because copper is the only metal which we have to study according to new reduced syllabus in this chapter. So let's take first condition, when the acid taken is cold and it is dilute. So action of cold and dilute nitric acid. Cold and dilute nitric acid oxidizes metals, and in this particular case copper, to its nitrate. So copper nitrate will be one of the product, and liberates nitric oxide. Why? Because we are using dilute. Let's see the chemical equation. Copper plus 8HNO3 reacts to produce copper nitrate plus water, along with the production of nitric oxide gas. So this is one reaction when the conditions are cold and concentration is dilute. Let's see another condition, when the acid taken is concentrated, or the temperature is high, temperature is high, hot, and we take dilute nitric acid. So here nitric acid oxidizes metals to their nitrates. So here it will be copper turning to copper nitrate, oxidizes copper to copper nitrate, along with the liberation of nitrogen dioxide gas, because we are using concentrated acid. Let's see the chemical equation. Cu plus 4HNO3 reacts to produce copper nitrate. So copper gets oxidized to copper nitrate, along with water, and nitrogen dioxide gas is produced. So these are the two reactions which you have to learn according to new reduced syllabus. Please practice this, writing these equations, and remember the nitric oxide formed in different conditions. So this much for today, boys. Based on today's learning, there is an assignment for you. Please go through it, refer to your book, and solve it and send it to me as early as possible. Wish you happy Diwali. Until we meet next time, stay safe and do all things well.